Anish with PyMasters Scholars here. So today we have a problem involving 2D lists where we have to write a function that takes in a 2D list as a parameter, and we modify that list by rotating it 90 degrees to the right, or 90 degrees clockwise. So for example, let's say that our 2D list looks like this grid here, where the top row or the first inner list is 987, the second row would be consist of 654, the last or third row would consist of 321. When we rotate it 90 degrees clockwise or 90 degrees to the right, this would be our new modified list, 369, 258, 147. So notice how this column right here, this first column, 369, that became the first row, 369. If you read it from bottom to top in the column, that gets mapped to a new row, and bottom to top would read the same as left to right. So this 369, if you read it bottom to top, that would be mapped to this first row, and if you read it left to right, that would be equivalent. Same thing with this middle row right here. This 258 is mapped. This 258 right here is the second column in the original list, and that's going to be mapped to the second row in the new modified list. If you read it left to right, that will be equivalent as reading it bottom to top in this original list. Same thing with the last row. So that's the main thing that you needed to recognize. It is guaranteed that the list that we take in has an equal number of rows and columns. So that means that the number of inner lists is also equal to the number of elements in each inner list. So that main takeaway right there is that each column is mapped to a certain row in the new modified list. So for example, the first column is mapped to the first row, the second column is mapped to the second row, the third column is mapped to the third row in the new modified list. And every element is also mapped to a certain position in that new row. The bottom element in each column is going to become the first element in the new row that that column is mapped to. So for example, 369, this column is mapped to the first row, and 3 is at the bottom of the column. Or yeah, 3 is at the bottom of that column. It's in the last row. Now it's going to be the first element, or in the first column of the new row that it's mapped to. So last element becomes the first element in the new row. The first element in the column at the top row now becomes the last element or the last column in the new row that that column is mapped to. So as you read it bottom to top in the column, that will read the same as left to right in the new modified list where that column is mapped to a certain row. So every column is mapped to the row with the same index as it. So obviously the first column, which has an index of 0, or a column index of 0, is now mapped to row index 0. And that goes for every column, and then each element is going to be mapped, again, based on its row index in the previous list. It's going to be mapped to a certain column index in the new list, and depending on which row it's mapped in the new list. So 3 right here has a row index of 2. It's the last element in its column. And then you see right here, 3 right here, now it has a column index of 0. And the way that we figure that out is we do the length of the list, which is 3, minus the row number that that element is on right here. So the row index right here is 2. The length of this 2D list is 3. 3 minus 2 is 1. And then you see here that in the new list, it also has a column of 0. So we also have to subtract 1 from that calculation. So it should be length minus the column minus 1. That's how you get the new position of every element based on whichever row that that column is mapped to. So now, if we want to solve this in code, the best thing to do right now is to make a new array. We cannot, if we do try to modify this in place using this logic right here, we're going to get overlapping values. We're going to be assigning values to the wrong thing because we already changed the list beforehand. So we want to create a new list. And then we just want to change the reference of this parameter list to reference that new list once we actually create the final list. So this final list, we're just going to set that right now to an empty list. We'll call that fine. This final list right now should just consist of zeros. It should consist of inner lists, and those inner lists should be filled with zeros. The amount of inner lists it has should just be equal to the length of the grid, or however many rows the grid has. So we'll get however many rows the grid has using rows is equal to the length of the grid. And we want to figure out how many columns the grid has, which is how many zeros will be in each row for this final list right here. So the columns of the grid will just be equal to the length of the first row, or the length of any row. And then now we want to fill up this final list right here. So we need to add rows inner lists. So for I in range rows, we want to add column number of zeros to each inner list. So for j in range calls. And then for each row, we obviously need to create a new list. So we're just going to call that temp. We're going to set that to an empty list. And then we need to add column number of zeros to each of those inner lists. So temp append 0 in this inner loop. And then at the end, once we fill up each inner list, we want to append that to that final list, the outer list. So fin append temp. And then that should fill up that final list. And then, so that's just filling up the final list so that we have all the positions in place. Now we just have to modify those positions to reflect the rotated list. So we need to actually do our rotation logic now. So remember, for our rotation logic, what we want to do is we want to go through each column, and then we want to perform an operation on each column where we rotate that column 90 degrees, or we map that column to a new row, and then map every element in that column to a certain column within that new row. So in order to do that, what we're going to do is we have to first go through each column. So for, and then we can say I in range, or we could just say for call in range column, or calls, however many columns there are. And then now the tricky part here is for each of those columns, remember that when you read bottom to top in each column, that will read the same as left to right in the new row that that column is mapped to. So 369, as you read bottom to top, will read the same thing as 369 in the new modified list when you read left to right at row index 0. So because of that, we actually want to go backwards. We want to loop from bottom to top for each column. So to loop from bottom to top, we want to loop from the last row to row index 0. So the last row, so for row in range, and then we want to go from the last row, which should be the total amount of rows minus 1. We're going to go until -1, and we're going to count the index backwards by -1, obviously. We only go up till -1 because the range function will exclude -1, so really we're only going up to, we're only including 0 as our final index, which is the index of the first row. And then so now that we've traversed through the index of each element, what we want to do now is we want to set final at, and then whatever row we're setting at, the row that we're setting at will actually be equal to the current column index that we're on. We've already established that. So row or fin square brackets call. Remember, so column 0 should map to row 0, and then the index of each element within that new row, or that column of each element within that new row, should just be equal to, and then the length of, or we'll just say the rows, the total amount of rows there are, minus the current row that we're on, minus 1. And then we're going to set that position equal to, and then just the current element that we're on, which should just be grid at the whatever row we're on at whatever column we're on right here. So now we can try this to see if it works. So we need to create a new 2D array. We'll just call that values. The 2D array will fill it up with 9, 8, 7. And then the second row should be 6, 5, 4. And then the third row will be 3, 2, 1. And remember, we also have to change the reference of this original list to reference the new list that we just created. So this new list right here is fin. Right now we just created a new list. We haven't done anything with it, so we want to change the reference of our parameter list, the one that we pass in, to make it look like it was modified. So grid should now equal. So now it has the same reference as fin, which means that it references the same list. So now all the changes in fin will be reflected in grid. So now we can call the method, or we can call the function on this new 2D list we just created. So rotate 90 degrees, and we'll pass in the name of the 2D list, which is values. And then we can see the changes in values by printing it. And we can see if we get any errors here. This is unindented. So I think the issue here is that we changed the reference of grid, but we have not changed the reference of the actual values. Value still points to this list right here, which is why it's printing out that list still. So what we could do instead is we can just return grid, which is just going to return the final. And then we'll set values equal to whatever is returned as a result of the call, which would just be the final grid, and then we can print values. And then that should print our new 90 degrees rotated list. Compare that to the correct output, 369.258.147, 369.258.147. So that is how you rotate a 2D list 90 degrees clockwise in Python.